All right, welcome back, everybody. So I'll say a few words on the exam, just for a few minutes. You can ask questions, and then we'll explain to you the rules of the quiz. All right, the exam. So what should you expect? First, it's a computer-based exam. This is known as online Prüfung at ETH. So it's something that ETH has been starting a few years ago as an initiative to offer exams on computers. Who of you already had a computer exam? Oh, wow, that's a majority. On Zoom too? Please raise your hand if you already had a computer exam. All right, I would say it's probably half of the people. Yes, I do mean Moodle exam, right? Like in a computer exam room. And instead of writing on paper, you were on the computer. Yeah. All right, so some of you, but not all of you. So let me explain what's going to happen. First, it's exactly like in a paper exam where you go to some room at ETH, the TA team is there supervising you, you have limited time, it starts at a time, it ends at a time, and so on, and you answer questions. So from that perspective, it's pretty close to a regular exam. No material is allowed except that you are allowed to bring general dictionaries. So it can be a dictionary with definitions, like English and English definitions, or it can be a translation dictionary, like English to German, something like that. But it must be the kind of dictionary you find in a shop, right? Like not you yourself creating a small dictionary that doesn't work. It has to be from a publisher. Also, complete atlas and history of everything there is to know in computer science is not a general dictionary, right? It has to be really a dictionary with just English words. So that you are allowed to bring. You can bring a pen or a pencil. The paper will be provided by us, right? So you can write down if you want. But of course, the answers must be entered in the computer, right? So this is about what is allowed. You can also bring, a bottle of water, drink, snacks, and so on. That's also something that is, as usual in exams, this is fine, especially for long exams. It's totally understandable. All right. Then the exam itself will be on a computer. Everybody will have one, of course, and it's Moodle. It's the same Moodle environment that we are using in the weekly quizzes, except that it's a special server used at ETH specifically I can't manage to say it, specifically for exams, that is maintained in an exam environment. And apart from that, the look and feel is going to be very similar to your weekly quizzes. The exam questions will mostly be multiple choice, filling the blanks, or we ask for a number, a string, or whatever, automatically graded. There can be also drag and drop, that sort of questions. So it's similar to the quizzes, but there is one exception, is that the intent of the exam is not the same intent as the weekly quizzes. The intent of the exam is to assess your knowledge of the course material. The intent of the weekly quizzes is to motivate you to learn. That's not the same thing. So it means that we do not design the questions of the weekly quizzes in the same way as we design the exam questions. So in the weekly quizzes, sometimes the questions can have some ambiguity or, leave something open. And of course, the TA team will always consider your answers and adapt and so on and so on. Because again, it's to motivate you, right? So we will always listen. If you have a good argument for an answer and so on, we can accept it and so on. But in the exam, the questions will be more closed and carefully formulated, that there is no ambiguity. I mean, we can make mistakes, of course, then we fix them, but the goal is to really have something that is precise and that is rigorously assessing your knowledge. There can be three kinds of questions, typically the way it's seen at ETH. There are questions that are almost direct textbook knowledge of the course. It's like to see if you remember what we discussed directly in the lecture on a specific slide and so on. Then there are questions that give you an example and ask you to compute something or apply an algorithm or do something and find a result, right? So this is working on a specific example. And third, there can be questions that are there to push you more and make you think, asking you for something that we didn't necessarily directly discuss, but that normally you can deduce with your thinking if you understood on the big picture the material of the course, right? So there are these three kinds of questions. Something else is that the time of the exam is normally relatively long. I think it's 3 hours. Did we put 3 hours? You remember? It's 2:30 or 3 hours. Quickly confirm. I think it's 3 hours. 3? All right, thank you. So it is 3 hours. 3 hours is a lot of time. The goal is not to have a super long exam that is super complicated. The goal is to give you time. This is why 3 hours. We are adapting, of course, every year. Some years it was too easy, some years it was too complicated. Of course, the grades, it will not disadvantage you. But basically now we start finding a sweet spot that we limited the number of questions to just 60. I mean, this is the instructions I gave to the TA team, and I will check it's no more than 60. My hope is that some of you will be able to leave early, right? If I have a few of you leaving early, that's a good sign. But of course, you can leave, take your time and stay until the end to double check your answers and so on. My goal is that you are not stressed. And I always look at of course, the exam evaluations, or we have a feedback box at the end of the exam. And of course, if at the end of the exam, everybody says, no, this was too long, this was too complex, then I just adapt it the semester after that and take it into account, right? All right, so this is what happened. So 60 is less than the number of questions that we had last time. All right, but there will be no software installed, like you don't have to write any program in Python or whatsoever. It's really just going to be questions to answer in the Moodle. Is there any questions that you have on that? Any clarifications that I can make, to remove any uncertainty? Is there a question? Yes, let me look. So Abhishek is going to come back soon. So I'm going, there he is. Awesome. So Abhishek, we have a question right now. You're exactly at the perfect moment. So we can now take over and moderate. Or maybe I can do this one and then you take over for the next one. So will the format remain the same as in previous years? Well, it depends what you mean with the same. There will not be an earthquake in the way we redesign the questions, right? So there is globally a style of question, and it will more or less remain the same. But of course, it's not going to be the same exam. But I mean, I don't expect a big earthquake that it would be a completely different exam than in previous years. That's also the reason why we actually give you the previous exams. Normally, they are in the FIS examination archive, all the previous ones. We might need to send the 2 past exams of the last session and the session before that in case they are not yet in the archive. We will also put them in the Moodle, PDF exports, and then you can train on the exam. We just don't provide solutions, but I think the FIS has a community solution contribution platform. So of course you can discuss that and make your own proposals. Do we have a question? Another one?
Do we get a deduction of points if we answer a multiple choice question wrongly?
If your question is, do we have partial points? The answer is yes. So if you have, for example, no?
The question is, do you deduct points if you answer wrongly?
Oh, negative points.
Negative
no,
points.
We don't have any negative points. So that means concretely that if you don't know, then pick an answer at random. You won't lose anything, right? Because it's something that is part of what ETH also wants to enforce. We want to encourage you to try. We don't want you to be afraid of answering a question for fear of negative points. We always want you to try. If you don't know, maybe your intuition will drive you towards the right solution. So no negative points for a wrong answer.
And just to confirm, no programming involved.
You won't have to write any programs. Exactly. There is no, we had practical exercises in the lecture, but you will not have to write a program concretely. Oh, oh, this is me, you see? Yeah, wireless electricity still doesn't exist. Okay, thank you for this. All right, so there are no negative points. There are partial points. If you get some answers, but not all, you get partial points. Any other question? No other questions? In the room, anybody? Yes? I don't think we will just repeat question. We might reinstantiate or slightly change, but I don't think we just copy paste questions. Yes, with the remark that I made earlier, that the Moodle questions of the exercises might be more vague sometimes than the exam questions. It has to do with a teaching paradigm. I don't know if you heard. Have you ever heard productive failure? Professor Manu Kapoor at ETH. He basically ran studies that showed that if during the semester, if you give exercises and the exercises are not always as carefully formulated as in an exam, meaning that there are something that might be a bit ambiguous or not exactly exact and so on, it turns out that it increases the grades at the exam. And the reason is that but it makes you think more, it forces you to investigate, like, oh, this question is ambiguous, so I need to look it up to document myself and so on, and to forge yourself part of the knowledge that you own more, that if we directly give you the structure. So this is the reason why for the Moodle quizzes, the question style is slightly different, because we want to provoke you and get you to think. So this is, I would say, the main difference that there might be between quizzes and the exam. But apart from this minor difference, it's going to be the same style or the same format of questions. Yes? And you have a feedback box at the end of the exam. If anything was unclear or you're not sure about the question, you think we made a mistake, maybe we made a mistake, then in the feedback box at the end, you can write it down. And after the exam, we go through that and we see if everybody points to a question saying there's a mistake there, then we can fix it before we issue the grades, right? So it's not like we let the computer do the job. We check. We have plenty of double check rounds in order to make sure that this works. If we see that everybody gets a question wrong, then we think, okay, maybe we were wrong. And so we double check if our solution might not be incorrect after all, right? So we do all that. All right, any other question?
There was one more question asking, making sure that there is no programming in the exam.
Yeah, so we had a lot of programming exercises because programming is a very good way of making sure you understand the algorithms, right? Having practical exercises make sure that you understand the structure, right? But yes, at the exam, you don't have to program. But again, it doesn't mean that programming was useless. On the contrary, programming forces you to understand things in the details, right? No other questions? All right, shall we then practice? Quiz, okay. So here's how it's gonna work. I'm gonna switch. Oh, no, I don't want to do that. Exactly. So as you can see, I have plenty of questions there for you. And who heard of the game on TV Eiskagehundert? I don't know if it's still a thing. Maybe it's completely obsolete, a thing from, so some of you know it, right? So the idea is that everybody in the lecture hall will stand. Everybody in the Zoom room will raise their hand. So actually we can do it now. Please all stand, at least those who want to play. Of course, I'm not forcing anybody. And in Zoom, please all raise your hand. Everybody who wants to participate, please all raise your hand. You can click at the bottom of the screen in the Zoom window, right? You don't have to, of course. If somebody doesn't want to play, you don't have to. But if you want to play, please raise your hand. Okay. Not the TAs, by the way. The TAs is separate. I will explain for the TAs. All right. So what's going to happen now is that I'm going to ask questions you will answer them on Clicker on your smartphone, as usual, as we did during the semester on your laptop. And then it will be trust-based, of course, it's just for fun. When you get a question wrong, you sit again or you lower your hands. We are looking for the last survivor. The one of you with the longest streak of correct answers is the winner. In order to make things interesting, that's the Icegagger 100, the TAs are playing against you. So we have Abhishek right here, who's also going to answer questions. Do we have also TAs in the Zoom or on Mattermost? I saw Piriacorn, right? Okay. Anybody else? So it's going to be the two of you. So you're going to play against Piriacorn and Abhishek. And so we'll see if basically you manage to beat them or they beat you. We'll see, right? So it's going to be. Sorry? I'm sitting out this time. Oh, Piriacorn is playing. Okay, yeah. Then you have Piriacorn, but you can help her if you want. But you can discuss the answer. It's a collective thing, right? All right. Okay. Awesome. So are the rules clear? It's going to be trust-based, of course. I have no way to know the individual answer for privacy reasons, so I'm just trusting you. Okay. No questions? Shall we go? All right. So let's start here. Some of the questions you might actually already have seen during the semester. How does the number of terms grow with the number of documents in practice, experimentally? Is it hyperbolic, logarithmic, square rootly, linearly, or exponentially? Some of the things I might even have said today again in the recap. Okay, so I'm giving a bit more time for the first one to make sure that all the apps work. You know that a few years back, there was a bug in the Clicker app that on the last day of the semester, the Clicker app would stop working. Fortunately, it was pre-Zoom, so we just did it in the lecture hall with the groups like on the front. But fortunately, as you see, it's working today. So I actually confirmed with them that the bug is solved. Okay, 27, we stabilized. 28. Does anybody need more time? Please let us know if you need more time. Otherwise, we're going to consider that everybody who wanted to answer has answered. All right, so now I'm going to try to time it when the TAs give their answer. I'm going to prepare clicking right here. So what is the TA answer? Did Piriacorn give an answer on Mattermost, I imagine, or somewhere? Oh, no answer? What is your answer? You can just do... Okay, I'm clicking at the same time. So yes, the correct answer is square rootly. And we got 21 correct answers. And so as we do so, of course, it's okay. It's just a game, right? So if you didn't get it right, then you can lower your hand or sit, but you can continue to play, right? You can still continue to answer and so on and play the quiz. And those who are still sending are still running for the longest streak, right? So everybody can continue to participate. All right, so we have 12 raised hands on Zoom, and we have in the room 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 and 12, 24 in the competition for the longest streak. Okay, next one. Why is the standard inverted index called inverted? Is it because it is always drawn topsy-turvy by convention? Is it because it maps terms to lists of documents, whereas the natural storage of a collection is a mapping from documents to terms? Is it because documents are sorted in inverted order of term frequencies, or nobody knows? You can still play, right? Even if you got the first one wrong and you're sitting, you can still play on Clicker, right? You are encouraged to continue to answer questions. Okay, so preparing to click here. What is the official global TAT answer? Yeah, that is correct. So the majority is right and the TAs are right. Indeed, a document is basically listing terms, right? So the natural way, hopefully when you read a book, you want to read terms in the right order. But in the index, it's the other way around. You have the terms mapped to the documents. The documents sorted in inverted order of term frequencies. This is something we covered. The reason it's not sorted by term frequencies is that if you do, the order is different for every term, and you cannot use the intersection and union algorithms, right? So this is the reason. All right. So let's recap. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 still standing in the room for the longest streak, and 11. So 21 still competing for the longest streak. Okay, now I'm accelerating a bit, of course, because there's plenty of questions. Which information retrieval technique is most adequate for evaluating this query, summer and not June or sum? Language models, Boolean retrieval, ranked retrieval, probabilistic information retrieval. This should be an easy one. I think that even somebody who didn't take the lecture would probably be able to answer that one. All right. What is the global TAT answer? Yes. Yeah, you made it all. 100%. I'm proud of you yet. All right. Okay. Next one. What is the most accurate definition of a type? This one you already saw. It's an equivalence class of tokens. If two tokens appear in related documents, the associated posting appears only once for each term, or it's the resulting set of a query expansion used to query the index, or it's an equivalence class of documents. This induces an equivalence class of tokens as well called postings, or is it an equivalence class of words where the types are associated with posting lists in the standard inverted index? $19, $21. Okay, 10 more seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. What's the T answer? Ah, it's the final one. So the students won. Actually, almost every year, you know, it's outnumbering, right? You are so many students that usually that happens. So why is the first one? Do you see why the first one is incorrect? So the first part is correct, but the second part of the first one. Yeah, so basically the first answer says that you merge across documents, right? That was the trap. Yeah, exactly. All right, so who is still standing? 1, 2, 3, 4, 5, 6. No, 1, 2, 3, 4, 5, 6, 7. No, 1, 2, 3, 4, 5. Okay, I have to every time. Really? Wow, 1, 2, 3 still standing in the lecture hall. And so you basically fell for that, right? It's that second part that is incorrect because we don't merge across documents. Let's see. On Zoom, we have 8 plus 3, so 11 of you are still competing for the longest streak, right? So this was a tricky one, right? Yeah, this was a tricky one. All right, let's go to the next one. What is the Dewey decimal classification? Is it the core algorithm used by Google to index the web? Is it a number-based system used by many libraries in the world to store and retrieve their books? Is it a standard used by mathematicians to classify sets, or is it some Boolean query? All right, 10 more seconds. I have to accelerate a bit. 9, 8, 7, 6, 5, 4, 3, 2, 1. What's the TA answer? Yes, exactly. That's been used in libraries for ages. It's a way to classify the books, right, according to topics. All right, the first one is called PageRank, the Google algorithm, and the third one is just made up by me. All right. 7 still standing on Zoom and 3 in the room, so we are at 10. All right. Which query returns documents 5 and 8? You are Y, you are not Y, you and Y, or you and not Y. Documents 5 and 8. All right, 10 more seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. What do the TAs say? Exactly, U and Y. Yeah, 26 votes. You see, there's only 5 and 8 that are on both. If you do the intersection, there's only 1 and 1. Of course, it's not the positive list here, it's the matrix, but nevertheless. Okay. So we have 7 and 3. We are still at 10. We are competing for the longest streak. Then we have, I think, this one. Oh, I think I just misclicked somewhere. Probably, oh, there. Yeah. Which one of the following is the standard inverted index for this collection? So this is a collection of 4 documents, right? And I'm giving you the bag of words representation. And you have to pick one of these 4 standard inverted indices as being the correct one. Some of them you can probably obviously eliminate just by looking at them, right? Yeah, absolutely. Let me roll the screen a bit. So these are the first 2. Then I roll down to the 3 and 4. These are the first 2. And these are the last 2. So some of them have numbers on the left, some of them have letters on the left, you see, and these are the documents. Okay, 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. The second one, and you are correct. Okay, so these 2 are wrong because here we have 1, 2, 3, 4. These are not terms, these are the documents. And here, this is not the format of PostFix, right? We have several numbers there. That would maybe be a positional index or something of the sort, but here we say the standard one. So this is the correct one. You see here we have the document frequency, we have the postings, and if you check, for example, A is in all 4 documents, and you can see A is in all 4 documents. Okay, now we have 3 and 6. We are at 9 of you still competing for the longest streak. Let's go to the next one. Inexact topcare retrieval. Do you remember why inexact topcare retrieval makes sense? Is it because precision is irrelevant to ranked retrieval? Is it because it leads to increased precision and increased relevance? Is it because the cosine computations are already an approximation of reality, or maybe it doesn't always make sense? This is one that I already asked during the semester. So let's see if your memory can bring it back. 20. All right, 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. 3, yes, exactly. It's because the cosine is already an approximation, so you're just approximating an approximation. Okay, very good. We are 2 in the lecture hall and 6 on Zoom, so we are at 8. Let's go to maybe evaluation measures. Which one of these ratios did we not define as evaluation measure? It's also one that I asked. True positives over returned results, true positives over relevant documents, true negatives over non-returned documents, or true negatives over non-relevant documents. 3 of them we defined, 1 of them we didn't. And I'm asking for the one we didn't measure. $22, $25. All right, 10 more seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, and C, yes. Okay, the first one, true positives over return result, is precision. The second one is recall. And the fourth one is specificity, right? And it's the third one that we didn't define. Yeah, I think we should give it a name at some point. Probably deserves one, but I'm not aware of any. All right, so we have 2 and 4, 6 of you are still in here for the longest streak. Okay, let me take this one. Which one here is the correct base formula? You see how I was careful with the notation. That's why I explained, right? Big A equals small a. Big A is a random variable, which, even though it's called that way, is actually not a variable. It's a function from omega to some place. And the small variable are the real mathematical variables. One of them is the base formula. $20 answers. Ten more seconds. 9, 8, 7, 6, 5, 3, 2, 1. The first one, yeah, exactly. It's actually making sense. This is the chain rule. That's the probability of the conjunction. And if you divide by B, then you get the conditional probability. Right, so the proof is straightforward. 4 and 2, everybody is still here. Okay, well, then let me use that formula. 3 boxes. In box A, we have Luxemburgerli from Sprüngli. In box B, we have 2 Toblerone. And in box C, we have one of each, a Luxemburgerli and a Toblerone. You pick a box at random, you bring it home, you open it and pick one. Happens to be a Luxemburgerli. What is the probability that the other candy is also a Luxemburgerli? Is it 1/3? Is it 1/2? Is it 2/3? Or is it 1? That's called the Bertrand's box problem, I think. $20 answers already. $22. 24. So of course, on exam day, you can answer with your intuition, right? As we said, no negative points. 24. Okay, 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. No, oh, sorry. Yeah, Luxemburgerly is from Sprügli. Yeah. Half. All right. It's actually the majority. Everybody said half, and this is indeed the trap, because this is why it's a paradox. And the correct answer is, in fact, 2/3. I can first give you the intuitive answer, and then I'll give you a slide that computes it with the base formula. The idea is this. The probability that the other one is also a Luxemburgerly is technically the probability that the box you picked was the one with the 2 Luxemburgerlies, right? So now you know that the one you picked is one of the Luxemburgerly. There's 3 of them, 1 that is alone and 2 that are in the box from Sprügli. So if you take among these 3, 2 of them are in the box you're looking for and 1 of them is not. This gives you 2/3. But of course, this is just an intuitive argument, and I can give you the formal version. How can I do that? I think I can probably open. Let me try to do it in that way. If I open, I think this one, let me try. Yes. So you see, these are the, oh, I'm too small. I have to make myself bigger. Something you can do in the metaverse, that's the good thing. This is box 1, this is box 2, this is box 3. The probability that we have the box with the 2 Luxemburgerlies, depending on the fact that you picked a Luxemburgerly, you apply the base formula, right? This is this. Now you have the probability of picking a Luxemburgerly, knowing that the box has 2 of them, it's 1, right? You know it has only Luxemburgerlies. The probability that the box is the 3rd one is 1/3, right? So that's 1/3. And the probability that you pick a Luxemburgerly is 1/2. That is the prior. This is probably why most of you actually answered 1/2. That would be the prior probability before. All right. No, I'm telling you nonsense. It's not the prior probability. The prior probability would be this one, right? But basically, this is probably what gave the confusion with the 1/2. But anyway, if you write that down and you multiply 1 times 1/3 divided by 1/2, you get 2/3, right? Do we have comments? I see there's comments on Zoom.
So this is basically the Monty Hall problem, more or less.
I would say yes, if you consider that the pattern to solve it uses the base formula in pretty much the same sort of calculations. You could basically consider it a variation of the Monty Hall problem. And I can build as many variations as you want. You basically just need to write the formulas like that and find the story where there's an unnatural way in the orientation, and then you just swap them in things that you can compute, right? So basically, I would answer yes, this is pretty much similar to the Monty Hall problem, all right? Okay, so now we have 1 of you in the lecture hall still standing, and in Zoom 3, so we have 4 of you, right? This is a tough competition, right? All right. So let's continue then. Is this a bad engine? That is in the sense that it's totally useless and you can't do anything with it. I realize I have only 6 minutes left in order to find a winner in the 4. So I have to try to find the questions that are the tougher ones. All right, 10 seconds. 9, 8, 7, 6, 5, 4, 3, 1. What do you think? Yes, it's actually not a bad engine. You just swap return, non-return, and return what you didn't and don't return what you did, and then you get a great engine. A really bad engine would be the diagonal curve. This is pure noise. But basically, imagine that imagine that you have, I don't know, a financial advisor on the internet who gives you whether the stock market will jump or go down the next month. They have been wrong every month for 30 years. Do you ignore them? I don't think so, right? You just take the opposite of what they say. So it's pretty much the same idea. Okay, so 3 and, oh, we still have 4 of you. Okay, let me find. Language models, maybe this one. All right. Here's a query, foo bar foo, and we want to use language models, bag of word semantics, no smoothing. And these are the documents. I want to rank them, and I'm asking for the one result that is returned on top with unigrams. Is it bar 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 bar, bar 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 foo, bar bar foo bar, foo bar foo bar, foo foo bar bar, or foo foo bar foo? Language models, unigrams, no smoothing. Right, 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. What do the TAs say? You would have said the last one, right? Yeah. And, oh, a lot of you said foo bar foo bar. And the correct one is actually foo foo bar foo. Of course, you don't have to believe me. I can show you the numbers. I will show you the numbers here. There you go. See, these are the documents. I build a language model with the probability of bar and foo, right? So here we have 3/4 bar and 1/4 foo, right? So these are my probabilities, unigram. So this is why I take one at a time. And here I compute the probability of generating foo bar foo up to a factor. Why up to a factor? Because I'm dropping everything I don't need. I told you the constant. I'm dropping the multinomial distribution part to turn the list of words into a bag of words. I'm dropping the p stop and 1 minus p stop. These are the constant. All I'm keeping is the product of these two. So here, the probability of generating foo bar foo is 0 if you have something that always returns bar. The probability of generating foo bar is 1/2. That's the probability of generating foo bar foo given that document, which is 1/2. So here it's 1/8, right? 1/2 times 1/2 times 1/2, right? And here it's the maximum. It's actually 1/4 for bar and 3/4 for foo. And actually you multiply 1/4 times, 3/4 times 1/4 times 3/4 gives you 9/64. It's very close. So the one that is 1/2 is here. That's 1/8, that's 8/64. So we have 8/64 and 9/64. It's by a very small margin, but it is the 9/64 that wins, right? This here is literally an application of the formula of the lecture, dropping the constants, the ones that do not vary. All right. How many people do we still have? 2. Wow, 2 people. We need to find a winner. Let me go back to the questions. All right. Okay. Encode the following postings lists with a gamma code 1, 3, 5, 50, 52, 500. Using the tricks that we saw, right? That with the gaps and so on. I hope that we can get the winner this time. All right. All right, you can try to guess or to use You know, you don't have to compute it all, you can deduct it, right? So 10 seconds, 9, 8, 7, 6, 5, 4, 3, 2, 1. And this is the correct answer, the first one, right? Remember that we encode the gaps. So it's 1, 2, 2, 45, and so on and so on. The first 0 encodes the 1. 1, 0, 0 is the encoding of 2, and so on and so on, right? And now I anxiously look at whether, oh, yes, 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 we have one winner. And the winner is Andreas. So now I want both on Zoom and in the lecture hall a big round of applause for Andreas. Awesome, congratulations. So this is it. This is the end of the semester. This is the end of the lecture. You still have the exercise session. I will help one of you connect the laptop if you want to project it right here, if you want to stay. And you will look at the language models in the exercise session with Andrea. Right, so thank you, everybody. Thank you for being such an awesome audience, right? These are challenging times. We started online, hybrid, and so on. Hybrid is here to stay. I will continue in the future to offer in the lecture hall, and you can follow on Zoom, and you can watch the recordings, and we'll just keep improving with time, right? So enjoy the resting time, enjoy the exam preparation. We are still here for you. You can ask questions on Mattermost. We are here to answer them. We'll provide you the past exams. See you at the exam, and all the best also for the continuation of your studies. And for some of you, see you in fall. Thank you very much.